Good evening, sir.
Yes, good evening. Coming to the end of the program. Last
Yes.
day.
Jamovi was easy, sir.
Yeah, Jamovi is now picking up the pace everywhere. Now, as and when the people understand how to use it, they are now SPSS and all other softwares have been replaced by Jamovi.
Shall we start, sir?
How many are there still?
Still 20 members set to join.
Okay.
Some are watching only in YouTube.
That is true. That is more convenient. They can, no doubt, there will not be a live session for them. It will be just understanding how to use it.
Yes, sir. Now, daily, every evening, we are posting the links to them. So they are watching by YouTube and learning.
Mm. Just wait for 2 more minutes, I think. Then we can start.
Yes, sir. Okay, sir. Until that, if anyone have any doubts, you can ask, sir.
True. Yeah. So that way, it is a closed group. Very few participants are there right now. So yeah, Dr. Augustine, Dr. Angana, Ekta, any query, anything you want to ask here, you can utilize this time.
You can unmute and speak.
Dr. Angana, Dr. Augustine, Thania will join, Manju, K. Amutha, someone with Motorola, Veena, Miruna. You can unmute and ask if you want, if you have any query, if you have any something to ask about it, or if you want to share something. 1 more minute for you.
Good evening, sir.
Yeah, Veena.
Sir, in recent days, sir, in many of the theses, we are coming across the findings like many of the findings are significant, sir. How is it possible, sir? And in some cases, it is not significant, sir. Is
So
the
you're
flaw is
talking.
with the data, sir?
It is actually based on the data only that you can conclude that whether it is significant or not. That is purely based on this data only the conclusion is made. So the sample size, if it is bigger and bigger, you can strongly say that your analysis, your conclusion is much reliable.
Okay, sir. Okay, sir. If it is smaller, then it is not significant, sir.
Ideally, yeah, the sample size is big enough, should be big enough, depending on the problem that you are dealing with. Suppose it is a cancer patient type of problem, your sample size will not be big. But if it is a diabetic type of problem, or if it is a salary kind of a variable that you are considering, or the distance that you are covering, that kind of variable you are doing, including, try to have a more sample size, bigger sample size, so that your results will be more authenticate.
Thank you, sir.
Thank you, Veena. How are you?
Yeah, fine, Sai. How are you?
Fine. Sir, I think I have introduced Veena to you in the previous program. She is my colleague.
Yeah, I recollected. Yeah. In
Thank
one
you.
of the session, I think she introduced also.
Yes, sir. Yes, sir.
Okay, I think now we can start. It's almost 7:04.
Okay, good evening to everyone. We are assembled here for the online international workshop on statistics using Jamovi. We have our resource person, Dr. Paraksha sir, Associate Professor from HL College of Commerce, Ahmedabad, Gujarat. So today sir is going to deal about correlation and regression. Welcome you, sir.
Thank you.
Sir, please take this.
Yeah. So Welcome for the last session of this wonderful program that we had. A very interactive and I would say something that Jamovi would help you a lot in your data analysis, understanding. And so the complexity of data analysis is now gone because of this open source software called Jamovi. Another advantage that we will be having is because it is an open source, anyone can use it, and the results that you get from that doesn't need a licensed version to be represented in your research paper and so. So that way, this will be very helpful for you in research. But the bottom line is you need to practice. If you understand the concept of statistics and you practice it regularly, I'm sure your results, your research, your findings for the industries will be much more acceptable everywhere. Right? So see to it that you do it on regular basis for your own data, for the industry data if you're working for industry, for your own research, or if you're getting some students for that kind of data, but use it regularly. And this is some of the features we have included, some of the techniques that we have included in this kind of workshop. This is a level 1 workshop in which we have included quite a lot of things which are normally, I would say 80-90% of this techniques or your research will be incorporated in this statistical techniques only. So that is why we have included in this level 1. Later on, we can have, as and when demand arises uh, across the participants and across other part of it, we can have level 2 in which we little bit more advanced techniques can be statistical techniques can be incorporated, and we can have a workshop designated for that. So that way we can plan it out at a later stage. But first is to clear this concept, have a sound fundamental concept understanding of it, practice enough for it, and then we can go with level 2. Today we are going to do with correlation and regression. Again, the topic which applies to all domains. Whenever you talk about relationship, whenever you talk about, I would say, you want to find out something, whether the two variables, whether three variables, or whatever variables you are dealing with, you want to check it out whether that is any relationship between that, what kind of relationship is, the form of relationship that you want to find it out. All that will be studied. So sharing the data files, if you want, you can download and get it ready for the practice that we are going to do today. Today's session will be more hands-on. Again, I'm repeating it. More time will be there for practice, so that you can get a hands-on idea about how regression works, precisely for regression, because it 60 to 70% of the industry problems can be solved using 60 to 70% problems can be solved using regression. And there are a lot of different regressions like logistic regression, multiple logistic, ordinal regression, non-linear regression. There are many more. Actually, there are volumes and volumes of only regression. There are books only on regression. That important topic it is. That important and relevant. Yeah, Subhash, I'm sharing the data file also, so that you can practice it as simultaneously as I go on. Let me share. I hope you can download the files now. Subhashri, I've given handout also. Dr. Agustin, Elango. Okay. Anita, Ekta, Monjos, Nalini, Pushpa, Sridevi, Veena, Miruna. Just let me know that whether you are physically and mentally over here or not. Just write down something in the chat box. Yes or no. Yeah, that's good. Okay, someone from MS University also. That's good. Okay, Pushpa, Ekta, Subhashri. How about others? Okay, someone with Motorola. Okay, Sridevi. Okay, Anita, Dr. Angana. Downloading, that's good. Okay, Bhagyalakshmi. That's good. Okay, Mohandos. Though it is online, though it is virtual, we should feel that we are interacting with one another directly, physically. So be live on the chat board so that we can discuss. They can interact. Let me know once the files are downloaded. Okay, Amuta, Tanya, one with 1, 2, 3, 4, 5 number. That's good. Adeline Joy. Okay, Vina, you have downloaded. That's good. Nalini. Okay, Ekta, you have downloaded. That's good. Srija. Okay, Dr. Agustini, it is still downloading. Dania VR. Okay, Pushpa, it is done. Okay, done. That's good. Okay, so I assume now everyone has done, completed it, or initially you have to understand the concept. So till then, the downloading part can be done. Okay, Veena, that's good. Few files are already. I would be taking the previous data files also over here. Okay, Dr. Agustin. So let us start with the last session for this workshop. I'll start with first of all, what is relationship? Okay, relation. If I talk about yes, the one with Motorola who have written, yeah, in PhD, surely you can go with. In fact, okay, let me share as the person with Motorola. You can rename your device name so that I can address you with your name. Ideally, now Jamovi is an open source, and there is a community working on Jamovi. So, as in R programming language, in Jamovi also there are new and new, I would say, modules have been added in Jamovi. Initially, probably in Raju sir might have taken in his one of the session that other than what you have being displayed on Jamovi, the menus that you have in Jamovi, there are many other statistical techniques that you can download and you can have it on your screen of Jamovi. If I explain that, let me take that. Okay, Lata, now it's fine. If I go with that part, let me explain what I'm trying to convey to you. I'm opening my Jamovi. You can see the Jamovi screen that I have and you might be having it, the menus that I have and you might be having it would be different slightly. Taking more time. Let me check why is this so much time has been taken. Okay, now it's done. If you see your menu of Jamovi, you will be able to see only exploration, t-test, ANOVA, and regression or frequency. What I have done, I have also added factors for factor analysis. I have added JJ stats plot for advanced plotting. I have added snow clustering, that is for clustering, and there are many more other techniques that you can download. So this is plus sign on the rightmost corner of your Jamovi. There is a plus sign that are modules. As you require new modules for the, if you click on modules, if I click on this, it will show you these are the modules that you can also add in your menu. Okay, so it is not only that the things that are displayed on the normal Jamovi, only that much techniques are available. There are many more techniques that are available in Jamovi which you need to download. So what they have done ultimately, they have made things simple for you. Okay, they have not shared you the whole bouquet of the statistical techniques. Only the major needed one are displayed in the basic module of Jamovi. Then you can add on as and when required. You can add on the statistical techniques and accordingly you can apply. So coming back to this, the PhD part, yeah, surely you can use it. Nothing, no one can deny to that of how you can apply or why you are applying Jamovi. It is open source and well accepted worldwide. Okay, let me start with now this correlation and regression part. Coming back to the same, if you see the whole part, it narrows down. If you dig down deeper, it is ultimately level of measurement. The whole game of data analysis is in level of measurement. So here again, if your independent variable, which we call normally as x, if your independent variable that is x, okay, Lata, and your dependent variable, we take it as y. Okay, so there are two variables right now to start with. We say there are only two variables. Okay, two factors we can say. One is independent, other is dependent. What is independent and dependent? If I say sales of ice cream, that is one of the variables. and say temperature. These are the two variables. Now we know that the sales of ice cream depends on temperature. That means if the temperature increases, the sales of ice cream will also increase. If the temperature decreases, sales of ice cream will also decrease. This means my sales of ice cream is a dependent variable, which I call it as Y, and temperature is an independent variable, which I call it as X. Make sense? Okay. Your income, it depends on the experience, it depends on your qualification, it depends on your skills, and many more. So this means my income, which is a variable Y, depends on all these variables which are called independent variables, which are called X. Now it is clear, independent. So coming back to this, if my independent variable is categorical means what? Nominal or ordinal. And in my dependent is also categorical. Both my variables of my study or my focus variable, my decision variable, both are categorical, then the technique that I have to use is chi-square, which Raju sir has taken in yesterday. So when to go for chi-square ideally? When both the variables of your study, your decision variables, for which you want to find out relationship, if both are categorical, you have to go with the chi-square test. If both are continuous means scale or numeric. If both are numeric, then I have to go with correlation. If your independent is categorical, but your dependent is continuous, then we have to go with ANOVA. If independent is continuous, dependent is categorical, then you have to go for logistic. And there are many more. Let me explain with some examples so that it becomes more clear. Suppose I want to find out education level, okay, education level Veena, not necessary, depending on what you wanted. You can go for Z test also, you can go for binomial test also. So chi-square can be used for even more larger samples also or smaller samples. Okay, if one of your variable is education level and the second is whether your, I would say, geographical location, rural, urban, that way, to make things simple for you, rural or urban. I want to check whether there is any relationship between these two variables or not. This means whether a person is coming from rural or urban, does it affect the education level? That is what I want to check. Is there any relationship between these two? That is what I want to check. So we need to do is check it out. Education level. Education level means what? Schooling, undergraduate, postgraduate, then it can be PhD and so on. So which type of variable it is? It is ordinal. Rural, urban, it is nothing else but nominal. But ultimately, this is what? Categorical. This is what? Categorical. If both are categorical, and if I want to find out relationship between them, so now you can see both are categorical, and I want to find out relation between them, I'll have to go for chi-square. Make sense? Okay. If I say I have my one more variable, income. So now we know income is what? income is a scale variable or a numeric variable. That means it is a continuous variable. I want to check whether there is any relationship between income and education level. Income and education level. That can be the problem, right? So my income depends on the education level. Suppose if I start with that, so this is my dependent variable. And this becomes my independent variable. So you can see independent variable is categorical, independent variable is categorical. And what is a dependent variable? Income. That is continuous. So I have to go with ANOVA. I want to check whether the education level affects the income or not. That you have already studied in ANOVA. If I say I have one more variable, say it is age. Now we know age is nothing else but it is also scale, that is numeric or continuous. I want to check whether there is any relationship between income and age. I want to check whether there is any relationship between income and age. So what is income? Continue. What is age? Continue. Then I have to go with correlation. Getting the idea? Okay. If I want to check, okay, I'll take one more. Fifth. I say whether a person is having car or not. Yes or no? Yes, no. Okay, yes or no. I want to check, okay, I want to check whether the person is having a car depends on income or depends on geographical location or depends on education level. So before that, we know that whether a person is having car or not, yes or no, means it is a nominal variable. Nominal means categorical. I want to check whether a person has a car or not depends on what? Does it depend on age? Does it depend on income? Does it depend on geographical location? Does it depend on education level? So that means my car is my dependent variable, okay, which is your y. If your y is nominal or categorical, and your x can be any, it can be continuous, it can be continuous, it can be no categorical, or it can be categorical, then we have to go with a logistic regression, which is not included in the basic level of statistical analysis. This is how logistic regression or regression has been considered. Done. Sure. Coming back to today's session, what we will do is when both variables are continuous, and I want to find out relation between them, then I'll go with correlation. So what is correlation? Relationship between two or more variables. That's it. Two or more. If there are two or more variables, then I want to find out relation between them, and they should be continuous only. They should be numeric only. Then I can go with correlation. Correlation. Now, this is very important statement that we all have to be clear with. Correlation doesn't imply causation. That means cause and effect relationship is not necessary in correlation. This means income in India, we know it is continuous. Rainfall in USA, this is also continuous. I can find out correlation between these two variables. I can get a value of R for correlation between these two variables. But I cannot say that income in India depends on rainfall in US or rainfall in US depends on income in this. There is no cause and effect relationship. There is no cause and effect relationship. And so, this is a very important statement. Correlation doesn't imply causation. We can have a correlation, it doesn't imply that there is a cause and effect relationship. Because if there is a cause and effect relationship, it is meaningful. It is meaningful, like temperature, sales of ice cream, or sales of AC, air condition. There is a cause and effect relationship. Here also we can have correlation. Here also we can have correlation. Both can give you the value of R. But in both the cases, there is not cause and effect relation. There is not cause and effect relation. Here there is cause and effect relation. Here there is cause and effect relation. So if you have a cause and effect relationship, it means it is a meaningful correlation. Otherwise, it is called a spurious or a nonsense correlation. This is a spurious correlation. But mind well, it is a correlation. Or it is also called, in a layman language, nonsense, which does not make any sense. That is correlation. Now, correlation can be, this is okay, I'm not going into that detail. That's okay. Correlation coefficient, yeah. Yeah, Shubhasri. They are not dependent on each other. They are not dependent on each other. So you can say they are independent variables. For independent variable also, we can find out correlation. You are on a right track. Okay. To find out how much there is a relationship, how much correlation is there between the two variables, we normally use correlation coefficient, which is denoted by R. Again, the same logic, which I took it for hypothesis testing. Whatever calculations we do for population, they are called parameters. Whatever calculations we do on the sample, they are called statistics. If I talk about mean, for population it is mu, for sample it is x bar. Now you all agree. Standard deviation, for population it is sigma, for sample it is s. For proportion, population it is capital P, for sample it is small. Same way, if I use correlation coefficient, R is so famous because we normally go for sample statistics only. We go for sample only. But actually for population, it is denoted by rho, RHO. So population correlation coefficient is denoted by rho, this way, rho. Okay. So for sample, we will use R. But when we do it for the population, it is always rho. Now we need to check the same way. As we checked for x bar and mu, we have to do it for R also. This means if I say GDP, okay, GDP and say exports, I want to find out whether there is any relationship between these two or not. Whether there is any relationship between GDP and export or not. So what I'll do, I'll take some data. I'll take some last 5 years data of GDP and some 5 years data of export. So this is, I'm taking 5 years data only, 1, 2, 3, 4, 5 years. And I'm finding out what is GDP, what is export, and so on. So this becomes a sample. And from sample, I'll get R only. But I want to interpret for all the data, that is for the population. So we need to check whether this R is significant for the population correlation, or this R is still significant between the, suppose the value of R comes to 0.45. Should I conclude that there is a significant correlation between GDP and export for the whole population? And for that, we need to go for testing of correlation coefficient. If you recollect what we were doing it, We were calculating X bar and we need to check whether it is the same for mu or not. We were calculating small p. We were still checking whether it is same for capital P or not. Same thing can be done for correlation coefficient also. So what we do in correlation coefficient, step 1 and 2, if you go with the same logic, step 1 and 2, null and alternative. So we say rho equal to 0 and rho not equal to 0, always. Rho equal to 0 means this is null, this is alternate. So what we say rho is equal to 0, no significant correlation. And here we say it is significant. Step 3 is to check assumption. What will be the assumption over here? That both should be continuous variable. Both continuous variable. Then step 4, take statistics T and the p-value. And step 5 is a conclusion. P greater than or equal to P greater than alpha. We accept. In very simple word, greater than means less than alpha. We reject. We'll do the same steps now. Okay. So now I'll take a case study. I'll take an example. Open a file, body temperature. In Jamovi, open a file, body temperature. It is a text file. Data is ready. Always, once you open the data, now look at this part. Open the data. Now check whether your variable level of measurements are proper or not. So you can say variables. Gender, it is showing by the 3 circles, means it is categorical. Okay. Age, you see it is, they are showing it as nominal. What is age? Age is continuous. What is heart rate? It is continuous. What is temperature? It is continuous. Okay, now it's fine. So now you can see that my data, gender is categorical by 3 circles and A is written. Age, it is showing the ruler. Ruler means scale. Heart rate is scale. Temperature is scale. Okay, now I'm happy. Then up to this, always check that in any software. Once you load the data, first of all, check whether the data has been understood properly by the software or not. That is the first thing that you need to do. Okay, this is done. My data has been ready. I want to now check, see what is the question, what is the problem. I want to check, is there any linear relation between body temperature and heart rate? This is what I want to check. Is there any linear relationship between body temperature and heart rate? So which are my focus variable? Body temperature. What is the second one? Heart rate. Okay. What I'll do is, now I'm starting with 5 steps. Step 1 and 2. Null and alternative. It is fixed. Null means rho equal to 0. Means there is no significant correlation. No significant correlation between heart rate and temperature. Alternative, always will have to take rho not equal to 0, means there is significant correlation. Step 3 is assumption. Which are the 2 variables for which we are finding out the correlation? One is heart rate and other is temperature. We can now, mere by understanding the problem, we can say both are continuous. When both are continuous, then only we can go for correlation. So now that is done. So now I'll go with step 4. I'll find out T, I'll find out P, and then in step 5, I will conclude. So now we go to the Jamovi part. So first step 1, step 2 is written, step 3 is done. Now I'm going into Jamovi. So my Jamovi is ready. Okay, where to go with? Analyze, exploration, okay. You can go with descriptive also. I'll show you all the options what can be done. So first understand. I want to find out between heart rate. I want to find out between temperature also. These are the options that you can go for. For both variables, it will be showing. See on the right hand side. For heart rate, missing, minimum, maximum, median, mode, and so on. Everything will be given. We are not interested in this. Just go in the plot. In the plot, you can go with a different type of histogram and check how the graph is looking like and so on. That you can go for. You can go with scatter plot, you can go with sim plot, and then so on. I would suggest what to do is in X descriptive, go into the scatter plot directly instead of going with any other descriptive. Go into directly this part, heart rate as X, temperature as Y, and go with linear regression. On right hand side, you will get the graph. Yeah, this is the graph. This is the scatter plot and it is showing you the regression line. This gives you an idea that it is increasing from left to right. The see the line, it is upward. That means it is showing that this is a positive correlation between the two variables, heart rate and temperature. So that means when the heart rate increases, the temperature also increases. Then I'll give the scientific reason also for this. But first, this idea, the scatter plot is giving you that when the temperature, heart rate increases, the temperature is also increasing. This was the scatter plot. Where to go for run? Exploration, go into scatter plot directly. So that is done. Okay. Now we'll go with the next part, that is how to find out correlation for it. That is a correlation matrix. So now again I'm going to this. I'm going into regression. I want to find out correlation. So I'm going to the menu of regression. I'll click on correlation. I'll click on correlation. I want to find out correlation between what? Heart rate and temperature. See on the right hand side, the correlation matrix is getting ready. Correlation matrix is getting ready. What is the value of R? 0.448 and the value of P is less than 0.001. So I have already taken for this. This is what you are getting. The value of R is 0.448 and this is less than 0.001. So if I go with step 4, my value of R comes to 0.448 and my value of P is less than 0.001. So now my step 5 is the conclusion. What is the value of P? Less than 0.001. Means it is less than 0.05. Even if it is less than 0.001, means it is less than 0.05. So that is done. When it is less than 0.05, what we say? Less than means we reject null hypothesis. Less than means we reject. So here we say we reject the null hypothesis. What was our null? Just recollect, rho equal to 0. What was our alternative? Rho not equal to 0. We reject null means we are rejecting this. So thus we can say there is significant correlation between heart rate and temperature. This is what you can do by pure logic, by our common sense. We know that when heart rate increases, temperature also increases. But we have to prove this. Statistically, we need to prove. And so we need to do this whole procedure. Okay, your data should also show what your common sense says, what your logic says, because now the whole world is moving towards data driven decision. It is not your no longer your gut feeling or your experience will be counted. It is only what data says that is important, and so this whole procedure needs to be done. Now scientifically, if you see, when you go for a run, okay, when you go for a brisk walking, the heartbeat, our heart rate increases. As our heart rate increases, the body temperature also increases. Now, as the body temperature increases, there is a mechanism in our body that if the temperature increases beyond certain level, then the nerves and the blood vessels will blast otherwise. And as the temperature increases to cool your body, we have perspiration. And because of that perspiration, the water starts evaporating and we feel cool part of it. And so the body temperature cools down. Okay. So you can see what happens that while you go for a run, you perspirate. Okay. Why this perspiration? Because the temperature of the body is increasing, and there is a mechanism in our body that when the temperature increases, to ease out that temperature, to lower the temperature, we start to perspirate. So the water comes outside, and so that is the reason the body cools down. That is a justification by the data that we have told. Any questions? Otherwise, we'll move to the next part, regression. Up till now, I've seen in research, because I'm into research journals also. I'm into editorial board of many national and international journals. In many non-statistical research, they find out R and they give it that, okay, the value of R comes to 0.67. And in the books, it is written, if the value of R is between 0 to 0.4 or 0.3, then it is low correlation. 0.4, it is moderate. Above 0.7, it is high, and so on. But this is not required. This is all which is wrong. You need to statistically prove this. And that is why this statistical test of T that we have used up till now needs to be given with your research paper, or with your thesis, whether you found out R, is it statistically significant? That you need to prove using it. You can do it for more than 2 variables also. Just go with the same Jamovi. If I go with age also over here, I'm including age. I'll get between 3. So what I'll get it, I'll explain the reason what we are getting it. It is a correlation matrix. So if my variables are X, Y, Z, here also it is X, Y, Z. We know correlation between the two variables, same variables, is always 1. X, X, Y, Y, Z, Z will always be 1. Correlation between X and Y will be same as correlation between Y and X. Correlation between height and weight is same as between weight and height. So if I write down a value over here, this is of no need. It will be the same. If I write down the value over here, this is of no need. And that is why if you see in Jamovi, they are giving only lower triangular matrix. Lower triangular matrix. So between temperature and heart rate, it is 0.448. Between age and heart rate, the value of P is 0.303. 303 means what? It is greater than 0.05. Greater than 0.05 means age and heart rate are not related. You can see here 0.10190, the value of P. It is greater than 0.05. Again, age and temperature are not related. And that is a justification for it, that age and heart rate are not related, age and temperature are not related. That data is also showing. So you can do for more than two variables also. So it will be a pairwise comparison. It will give you pairwise comparison. Okay? Subhashri, Lata. Yeah, for correlation, no need to check whether it is dependent or independent. No need to check. That comes into the picture when we go for regression. So when we go for regression, we need to understand the cause and effect relationship. We need to go for cause and effect relation. Good. So what is regression? Regression is a functional relationship between. Okay, let me give a practical example. We all know that sales of ice cream and temperature, sales of ice cream always depend. So this is my dependent variable. It depends on temperature. That even a small kid knows. Then what is for us? I want to know that if the temperature, we know this much, the temperature increases, sales of ice cream also increases. The temperature decreases, the sales of ice cream also decreases. But if I want the answer, how much, that if the temperature increases by 1 degree centigrade, how much sales will increase? Now that is practically very important. If I am doing an ice cream business, and if I come to know from the weather forecast that next 2-3 days the temperature is going to be 41 degree or more, temperature would be 41 degree or more, that means my ice cream sales will increase. But if I am able to know how much will be my sales, expected sales, then accordingly I can plan all my resources. I'll purchase more raw material, I'll get more ice cream manufactured, so that when there is a demand, I'll be able to earn from it. That is where regression comes into the picture. It gives you a function, it gives you a relationship like this kind. Y is equal to A plus BA. So that if you substitute a value of X, say 41 degrees centigrade, you will be able to find out how much sales you'll be getting it. You'll be able to get out the estimate of. That is where regression comes into the picture. So regression is nothing else but a functional relationship between dependent and independent variables. Make sense? I'm not going into much technicality for it, but practically, this is where regression plays an important role. Okay, Kanchan, good question. You can find out relationship between gender and heart rate using regression. You can. So, okay, let me elaborate this. I'm not going into this complex part of it. Yeah. If I say my y is equal to a plus bx, this is the equation, regression equation I'm getting it. Y should be compulsory continuous. X, which is my independent variable, can be continuous also, or it can be categorical also. I can use regression for that. So regression can be used to find out relation between two continuous variables, or between continuous and categorical variable also. Have I answered your question? Okay, Kanchan? Good. So now see this. Yeah, this chart will help you. My dependent variable is numeric, that is scale. Independent, scale. Then I can go for simple regression, simple linear regression. Your dependent variable means y, independent variable means x. If there is scale, independent variable can be continuous or it can be categorical also. I can go for multiple regression. If your dependent variable is binary, yes, no, whether to give loan or not to give loan, whether a person will survive or he will not survive, a person will be failure or will be successful, and then we have to go for logistic regression. So this is how regression can be decided, which regression to use. All these are regression. All these are regression, right? That is why I said there are volumes and volumes of regression that we can use, and major industry problem can be solved using regression. I'm not going into this technicality also. This is okay. Let me take one example. I'm skipping all this. I'll take an example and I'll explain with that only, so it will be more understandable. Otherwise, there is some complex statistical part of it, so I don't want to uh, discourage you by giving complexity of regression and complexity of statistics. Suppose the same data file, body temperature and X. Question is asked, built a linear regression model for body temperature using heart rate. So this means, now see how important it is. I want to find out a model. Model means equation. I want to find out a model, means an equation, which says that body temperature, that becomes my Y, using heart rate as a predictor. Predictor means independent. So that is your X. We already have found out correlation, and we say there is a significant correlation. So my next question is, if I say that my heart rate is 67, my heart rate is 75, then correspondingly, what should be the body temperature? That prediction, that estimation can be done using regression. That is what we are going to do today. Okay, now see how it is done. First step, go with regression. Okay, I'm using that. I'm going into regression. I'm going into linear regression, which is my dependent variable, temperature or heart rate, temperature, which is my independent variable, heart rate. Okay, so that is what we are going to do, heart rate. This is done. That's all. My regression model is done. That simple it is. My regression model is ready. You can see here. My regression model is ready. It will give you the model fit. It will give you the model coefficient. So simply what I've done, I have only kept my temperature as a dependent variable, and I've kept heart rate as a continuous, that is a independent variable. That's it. Only that much I have done now. And you can see all this, I'm getting it ready. Now let me explain what does it mean. Each one of the output that you get needs to be understood how it is done. So what I've done, temperature, I've taken it as Y, and heart rate I've taken as X. Right now I've taken only one heart rate. That is only one variable, that is heart rate. I can even put age over here also. Age over here. If I do that, this means there will be two independent variables, age and heart rate. Then that is called multiple regression. We'll take that example also. One example I'll take that for that also. But right now, this is done. Okay, this is my output. You can see in Excel, you can see in Jamovi, this is the output that we get. So this is the output that you got, in which it is showing you that the value of R square is 0.20. Understand each one of this. What does R square means? What does its practicality means? Coming back to my X, coming back to my Y. What was X? Heart rate. X means independent. What was my dependent variable? Temperature. Everyone over here, this is very interesting. My R square comes to 0.20. What does that mean? That means we say that temperature depends on heart rate. That's okay. Temperature depends on heart rate. How much it depends? That level of dependency is 20% R square. So this means, now I'm talking in industry viewpoint or in your research viewpoint. This means 20% of changes in heart rate in temperature is because of heart rate. So this 20% changes in temperature is because of heart rate. So the other way around, there are still other factors which should be considered, which is explaining your 80% of the changes in temperature. I repeat again. We all know that temperature depends on heart rate. But is it only on heart rate it depends? No. There are some other factors also which is affecting our temperature. So here in this data, that other factors are 80% and heart rate only contributes. This means practically, now if I explain, this means include more variables in your model. Only heart rate is not enough to estimate the temperature. Model is a good fit. You can see the value of P. The value of P is less than 0.001, which is less than 0.05. This means model is fit. Model is fit means this heart rate and temperature are fitting well. That's okay. But they're not enough. That is what R square conveys. Okay. That is why in certain books it is said that the higher the value of R square, better is the model. Many a times it is said that R square should be greater than 0.7. It should be closer to 1. Practically, let me say, practically R square will never be close to 1. It is only possible if you manipulate the data. I'll give you one incident. When I was doing consulting for an Australian company, it was a betting industry, Satta. It was a betting industry of cricket. So they asked me to create an algorithm in which ball by ball, I was able to predict which team is winning. Because in batting industry, every ball by ball, the bat has been played. In IPL also, you can see every ball by ball, the chance of winning of a team changes. So he wanted me to create an algorithm in which team is winning ball by ball I had to predict. I created an algorithm and you'll be surprised that my value of R square came to 0.52, 0.58, 0.58. Statistically, as a layman, if I would say, as a layman, someone would say this is too low. It is not a good model. It is not a good model. But here, practically, this is a very good model because my factor of winning or losing, it is very, 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 I would say, uh, by chance causes. There are many factors affecting the winning and losing ball by ball. So even R square of 0.8 is also considered to be a good model. So depending on what your data is, that R square has to be interpreted. Model is good. You can see here, model is good. But it is only explaining 20% of variations in temperature. There are still 80% other variables which you need to include. That is what R square is displaying. Okay, further. That's okay. This is done. Now next comes to, this is also done. Next comes to model coefficient. You can see your model coefficients are ready with you in the output here. Intercept, heart rate, that is ready. So here also, if you see, intercept is a constant. This is constant. So no need to look at the p-value and so on. Directly you can skip the constant. But for the heart rate, what is my value of estimated value? 0.0806. And what is my p-value? P-value for heart rate is less than 0.001, which is less than 0.05. That means heart rate is significant. So this is an important variable for us. It is a significant variable. I cannot exclude it. So this means you have to keep heart rate over here, and then it gives you the model. Final model will be given to you. And what is the model? This is okay. This is what I've explained. So you can see the regression model now. Y equal to, Y was what? Temperature. Is equal to constant 92.3907 plus 0.0806 heart rate. This is my model that I'm getting. Now someone comes to me. Okay, let me check this. Okay, someone comes to me and says that the heart rate is 69. I can estimate what should be the ideal temperature for him. If I substitute 69 over here, I will get 92.391 plus 0.081 into 69. Suppose if I calculate this, suppose I'm doing the calculation, 0.081, 0.0806 if you want. Okay, I'll take the whole thing. 0.0806 into 69, that comes to 5.5614. And this is 92.391. So plus 92.391, it gives you 97.95. This should be the temperature of that person. Now you can understand, when you run, your heart rate increases. So when your heart rate is suppose 80, automatically your temperature will increase. It will show you how much temperature your body will be having. And then the perspiration starts and so on. This is regression. Getting the idea? Okay, let me go. This is okay. I'm not doing this right now, checking the assumptions part. I'll go with the multiple regression. This is a multiple regression. What is given to you? I have a data of 20 patients where blood pressure is collected, age is collected, weight, body surface area, which is called BSA, body surface area, duration of hypertension, for how many years you have a hypertension, basal pulse rate, measure of stress. This all variables are given to you. Understand this example very clearly, because this is something which you can apply for your own research. This type of analysis, not the data, not the variables. Forget about the variables. But any such kind of data or variables will be there in your research also, or in the industry also. So what I want to do is, I want to predict, or I want to check my blood pressure is affected by which of this variable and how much. Doctor says that if you're in more stress, your blood pressure will increase. But how much? Doctor says You have to reduce your body, go for a walk, otherwise your blood pressure will increase. But how much my body surface area is affecting my blood pressure, or how much blood pressure is affected by age, my weight, that I want to check. Okay, your data is given in arterial blood pressure.cso, arterial blood pressure. So I'm opening that file now. This problem will clarify all your doubts of regression. Once you open the data, load the data, what is the first thing to check? Whether your data has been understood correctly by the software or not. You can see blood pressure. Blood pressure is nominal. Actually, it is continuous. Change that. Age, it is again continuous. Change that. Weight, it is continuous. Okay, good. Body surface area, continuous. Good. Hypertension, continuous. It's good. Pulse rate, they have taken nominal, but actually it is continuous. Okay. Stress, it is continuous. Or I can say stress is continuous. So there is a measure for stress that has been done. So my data is ready. Clear? See now how easy it is. Everyone over here. Or else I will be dictating it. You can do it accordingly if you're doing it simultaneously. Go into analysis. Click on regression. Okay. Click on regression. Click on linear regression. What is your dependent variable over here? Blood pressure. That is over here. All other variables, you keep it as a covariate. All other variables here. Automatically, the output is ready with you. Getting this output? Okay. I will interpret this now one by one. Understand this part. This is very interesting. This is what I have done, and this is what I'm getting. R square. Now you know. Now you know what is the value of R square. R square is 0.995. Means it is almost 1. This means, which is my dependent variable? Blood pressure. Which are my independent variable? Age, body surface area, stress. Then what else it was? Duration of hypertension. Weight. I think there are 1, 2, 3, 4, 5. Only 5 variables. One, two, three. Pulse rate. Okay. What does this shows? Okay, Shubhasri, 6 here. That's done. What does it shows? That I say blood pressure depends on this 6 variables. But how much it depends? It depends 0.995. That means 99.5 percentage variables or variations in blood pressure are because of this 6 variables. 99.5% variations are because of this variable. This means your model is very good. No need to go for new variables to be added, because 99.9% variations are already covered. In the previous example, what was our R square? 0.20. This means there are other factors which contributes to 80%, which you have not considered. Here, 99.5% variables you have already considered. So no need to include a new variable for it. So that is the first interpretation which R square shows you. So in practice, this means the variables that you included as independent are enough. No need to have more variables for it. Model is a good fit because P is less than 0.001. Less than 0.001 means is less than 0.05. So it is a good fit. So model is a good fit. Variables are also enough for you because it is explaining 99.5% of variations in the blood pressure. That one is done. Now the next and the important part comes to coefficient. As I said, take out the coefficient age. What is the value of P? Point is less than 0.001. Shubhasri, yeah. Bhagyalakshmi, R square can never be more than 1. R square will remain 1 only. I'll explain this also. This will be clear with this slide. For age, what is the age is a variable. What is the value of P? 0.00 less than 0.001, which is less than 0.05. Less than 0.05 means this is significant or this is not significant. Less than means what? Less than means what you can say? Accept or reject? We reject. So this means age is a significant factor. This is also less than 0.05. This is also a significant factor. What about this 0.046? It is almost less than 0.05. So body surface area is also significant. Now see the interesting part. This is 0.265, which is greater than 0.05. So hypertension duration is not important factor for predicting the blood pressure. 0.305, it is also greater than 0.05. So this is also not an important factor for predicting the blood pressure. 0.172 greater than 0.05. This is also not an important factor. So your model, now you have to create a new model in which you have to exclude hypertension, pulse, and stress. So I'm going back to this part. Okay, I'm removing in analysis, in regression, what I'm doing it now. Okay, I have taken this different one. Okay, this is not required. I require this one. Yeah. What I'll do out of this, which are significant? Age, yeah, age is significant. Is stress significant? No. Pulse rate? No. Hypertension? No. Exclude all that variable. No need to include that variables over here. Yeah, t value you have to, if you want to interpret t value, you have to compare with the t table value. So you need to have a table. That becomes very complex because if you have, you just write down in your research, you just write down that t is minus 4.61 and the value of p is less than 0.01. That much you can do. Okay, now see what I've done it. Once you exclude that variables, I've excluded that variables. Okay, now this is a new model I'm getting it. Now which are my variables? My y is blood pressure and my x, which are independent variable, age, weight, body surface area. Now there are only 3 variables. So So now I want to check how much blood pressure depends on these three variables. The answer comes to 99.3%. So even after excluding three variables out of six, what was our R square here? 0.995. How much is the change? Even after removing the three variables, it is 0.993. That means that variables were redundant of no use. So the advantage is now that regression. Let me give the whole idea how to do it. When you have a problem, like this is a problem that I want to check that how blood pressure is affecting. Blood pressure depends on which factors. This is a problem. Then have your whole team ready or your colleagues ready with you. Have a brainstorming session that blood pressure depends on which variable. Get the inputs from your colleagues or your from expert and include as many variables as you can. Someone says that age is also a factor, weight is a factor, height is a factor, location is a factor, geographical location is a factor, rural, urban is a factor. Include all that variable. In brainstorming session, include as many variables which are going to affect the blood pressure. Then run regression. Automatically, suppose you have taken 20 variables, regression will show you that out of 20, only this 4 or this 5 are important for us. Remove all other. So while brainstorming, don't restrict the numbers. Include as many independent variables as you can, which you feel it is affecting my blood pressure. Once I have done that regression, you can see now regression is showing you, this was the case. Regression is showing you that these three are not important. Include only these three which are important in predicting the blood pressure. So let regression model decide which is important for them or which is not. Don't use your common sense in it or don't use your expert knowledge on it. That regression says what the data is giving you. So here, data is saying that only these three are important for predicting the blood pressure. Okay, what next? This is done. Next comes to the final model. So now you see my final model. Okay, this is again p-value. This is okay. Now this is the final model. Intercept means the constant. This is the coefficient. Coefficient for age, coefficient for weight, coefficient for BS. So my model comes to that my blood pressure, sorry, it should be blood pressure, not temperature, blood pressure. My blood pressure is minus 13.410 plus 0.718 age, 0.896 weight, and my 4.553 body surface area. Now the important point, model is ready, that's okay. What it shows, understand, what it shows, the interpretation is very important. This means if my age increases by 1 year, if my age increases by 1 year, my blood pressure will increase by 0.718. That is why when you go to the doctors, they ask your age, they ask your weight, and then they decide whether this is a normal blood pressure or an abnormal blood pressure. Because age is affecting your temperature, your blood pressure. This means how much it is affecting. Coming back to the same question, I say that blood pressure is depending on age. How much? That is 0.718. If blood pressure is increasing by 1 year, then the blood pressure will increase by 0.718. That is what our data shows. So this means if a person age is 35 years and the person's age is 34 years, the difference in the blood pressure of these two will be at least 0.718, considering all other factors constant. Considering all other factors constant, The difference between this two age group persons, the blood pressure will be 0.718. Okay, that is one. Second, if the weight increases by 1 kg, then your blood pressure will increase by 0.896. If your body surface area increases by 1 unit, your blood pressure will increase by 4.553. So the most important factor which is affecting our blood pressure, you can see, is body surface area. Is your body surface area. मतलब आप कितना मोटापा है आप, how much fat you are. Okay, your weight may be not that much. Okay, your weight will not be that much because it may be that your bones are of that kind, but your outer, suppose for a person, this is the body surface area. If that is more, then your blood pressure is bound to increase. So how much, that is answer is given over here by this coefficient. So the coefficient says, again I repeat, if blood pressure, body surface area increases by 1 unit, the blood pressure will increase by 4.553. And that is why when you go to the doctor, first thing that they go for, reduce your weight. Because when you reduce your weight, ultimately they are asking to reduce your body surface area. That is how regression comes into the picture. No, no, Subhash. It is the other way around. This means body surface area is the most important factor which affects the blood pressure. In the other way around, actually, Subhash, as you said, the other way around. Actually, the most important factor is body surface area, then it is weight, and then it is age. Because body surface area is affecting 4.553 times the blood pressure, weight is affecting 0.896 times, age is affecting 0.718 times. It is the highest, yeah. Okay, this is how the whole thing is done. Now there are a lot of other practice sums I have given. You can utilize the same logic and go for the regression. Yeah, p-value is more, Kanchan, but it is less than 0.05. P-value, how much is the p-value is not important for us. Whether the p-value is 0.0005 or p-value is 0.001, that is not important for us. We just have to check whether it is less than 0.05 or not. That's it. Okay, with this, correlation and regression is done. I would say regression is very, very important. And I'm sure in one or the other case for your own research and research paper or industry problems, regression can be applied. Open for questions now. I'm done with the content. There are many more things, but I think at this level of workshop, we should not go with the more complexity. So this is the basic level of regression that we have all covered over here, which is important for all non-statisticians. We can do this one. Okay, so the thing that you are asking for, the model equation only we can conclude correctly. Yeah, from model equation only you can find out the perfect interpretation for it. Okay, Bhagyalakshmi, why R can not be greater than 1? This is very, very technical question. It is because of the formula. It is because of the formula that the value of R is decided in such a way. Let me explain it as you are asking now. The formula for R, is actually covariance xy upon Sx into S1. What is covariance xy? Covariance xy is variations between x and y, while Sx is variation within x, and Sy is variations within y. And covariance between x and y is always less than or equal to Sx to S. And so the range of R is always between 0 and 1. The value of R always lies between 0 and 1 because it is a ratio. We continually see R square. We always see R square. One surprise for you, in industry, no one looks for R. Correlation is of no use in industry. Because correlation gives you that there is a relationship between the two variables. Then what? There is a relationship between two variables, but how important it is for us? It is only important if you are able to say how much will be the change in the other variable because of X. And that answer is given by regression and not by correlation. So practically in industries, we never use correlation. Okay, any other questions? Okay, ma'am, Shailina ma'am, so I think we are done with the workshop, and thank you all for a wonderful interactive participants and participation rather. And there are many more workshops that Shailina ma'am is going to organize further, that to be in touch with her so that if you want to have a next level of workshops or the training program, she will be there to provide you at a very, very nominal rate. To be very honest, this is very, very nominal rate that she's providing this kind of workshop. Otherwise, there are people who mints money from it, but she's at a very nominal rate providing it. Okay, so what the question is, correlation. You say that R square can never be 1 in correct calculations in actually. So we can take it as R never be perfect. Yeah, Subhash, R square can never be in industry, in practical data, R square will never come to exactly 1. It may come closer to 1, but it will never be 1. So that is why we say the value of R square lies between 0 and 1. But it will never be 0, it will never be 1. Okay.
You can unmute yourself and then speak.
Yeah, that is also, you can unmute and give your experiences, how you found this workshop to be.
Yes, please.
Okay, Lata, Pushpa, you can unmute. Mohandos, Amutha, Subhashri, Veena. Okay, Veena is always there. Ekta. You can unmute and say and share your experience, how you found it.
Hello, sir. Good evening, sir.
Okay,
Good
Kanchania.
evening, sir. Well, thank you very much, sir. And thanks to Sailila madam also. It was very wonderful experience for us. We were able to actually practice many of the sessions, what yourself and sir was also doing for us for all these days. But the only thing we need to, now things looks easy for us, but we need to practice more and more with the exercises. And also we need to apply it and see with the, because for you things are easy, but for us even identifying what type of variable is little bit difficult, like independent or dependent. That needs more experience and we need to see lot of numbers. But with you it looks easy, and also with sir also. But now, but it was a wonderful experience for us. Jamovi was much easier. I have attended the previous SPSS workshop with you, sir, last some months ago. So compared to SPSS, I find this is more easier doing the analysis with the SPSS, the version of Jamovi here. But sir, we want to check with you and Sailila madam also. We want to know how to calculate the sample size for the population and thing. There are different sample size formulas we see in textbooks and all. And also we want to know how to check the content validity index, reliability coefficient. Because when we are doing PhD, we have to run all these analysis and things. So we really have difficulties to know this part of it. If another workshop can be focused on these parts, how to calculate sample size depending on the population, because when we go to the net, things are very easy. But when we really do practically, we don't know really why these things are done in such a way. Online formula calculators are there, but still we want to know practically how we calculate it and things. Also reliability, content validity index. So it will be very good if we will both arrange for us another workshop on all these topics.
Sure.
Thank you, sir. It was very wonderful experience for all of us. I think all our colleagues also who are here will go along with my saying. It's very nice experience, sir, learning with you and sir. It was Raju sir also. So very nice sessions. And I really appreciate Sailila ma'am for making such workshops continuously. Thank you, sir.
Thank you, Kanchana. Thank you.
Thank you Kanchan, for nice words. And I think, yeah, we noted the points, the inputs that you have given, and
Yes, sir.
for some other workshop, yeah, sure, we'll include that kind of topics also.
Yes, sir. Actually, item analysis part is also a big difficult for us. I think there are some find by serial method for item analysis. I don't know. For SR not type, what kind of
We can include
item?
the other topics also. So you can give your inputs to Sailina ma'am, and we'll design the syllabus accordingly for the workshop.
Yes, sir. We will think for this topic, sir. Okay.
Anyone else?
Good evening, sir. This is M. Kiran Kumar.
Yeah. Good evening.
Yeah, good evening, ma'am. Thank you for your very interactive session. I'm basically from a biology background, so statistics is a bit difficult for me. But these sessions really made put me at ease that I can do some statistics work. And Jamovi is very, I think, it will be very useful for us to do our data analysis or kind of a smaller data sets, to work on smaller data sets. And your presentations were very interactive, and you made us to interact in between, which I liked it very much. And Raju sir also explained very well, and particularly for people without maths or a statistics background, it was really nice. I assume that there will be a few more kind of workshops like this for people, particularly for people who are from non-statistical or non-mathematical backgrounds. So thank you very much. Thank you, ma'am, for arranging such a wonderful workshop. So thank you, sir.
Thank you. Thank you. Thank you for the kind words.
Thank you so much, Kiran, sir.
Thank you, ma'am.
Okay.
Okay, thank you very much, sir, for wonderful sessions. We extend our sincerest appreciation to you and Chaudhary, sir, for your invaluable guidance in learning Jamovi. Both of your expertise and patient instruction have empowered us to harness the full potential of this powerful statistical software. With all your guidance, we have gained a deeper understanding of Jamovi's capabilities, enabling us to conduct robust statistical analysis efficiently. Your dedication in facilitating our learning journey with Jamovi has equipped us with invaluable skills for data-driven decision making. We are immensely grateful for your expertise and support, which have undoubtedly enhanced our research, analytical capabilities and research endeavors. Thank you very much, sir. The feedbacks were very good. Each and every day we got very good feedbacks. Thank you so much, sir, for giving such a wonderful software for us. Thank you so much.
Thank you, and thank you all, and see you somewhere in some other workshop. Okay, bye.
Okay, sir. Thank you. Thank you so much. So the feedback has been posted in the chat box. You can fill it up. Check the feedback in the chat box. You will be receiving your certificate in a week. Kindly check the feedback link in your chat box. So thank you once again. Those who have filled the form can leave the session. So you'll be receiving your certificate in a week to your mail. Kindly check your mails. We will meet again on another session. So whatever you need to be focused on the next workshop, you please put it in the form, the feedback form, so that we will plan accordingly. Thank you.